Pose with the fans. Pose with the pose with the pose with the pose with the fans. Pose with the pose with the pose with the fans. Pose with the fans. Pose with the fans. Pose with the pose with the pose with the fans.
Hey guys, did you know when COVID-19 hit in 2020, Singapore economy faced its greatest recession since independence? The GDP fell by 5.4% while important industries such as tourism, retail, and aviation came to standstill due to global lockdown. Remember Changi Airport? It was awfully silent back there.
Yeah, it was a really hard time back then. But you guys, do you know what factor that really affect GDP in Singapore?
Maybe. How about we discuss the factors that affect GDP in Singapore?
I think many factors can affect GDP growth in Singapore. For example, like inflation, foreign direct investment, population growth, unemployment rate, and also trade balance.
Then, how do these factors affect GDP over time? Can this factor raise GDP during a recession?
Sure, during a recession, these variables might help to boost GDP. Moderate inflation increases consumption, while FDI attracts capital and generates jobs. Population growth also can boost employment and demand, but only if there are enough opportunities.
Also, lowering the unemployment rate encourages expenses, where a good trade balance enhances GDP by increasing export income. Together, this can help in recovery and growth in Singapore.
Oh, so grateful to hear this thing from you.
So how do you study the factors that affect GDP in Singapore? What are your objectives?
Our objectives are determine how inflation, population growth, trade balance, unemployment rate, and FDI affect Singapore's GDP. Then identify which factors have the most significant impact so that we can use econometric analysis to provide data-driven insight for better economic planning.
Now, we're moving on to the next part, which is econometric model that we have built to have an in-depth analysis on GDP growth in Singapore. But first, let's take a look at our initial theoretical economic model of GDP growth. In our early model, we take GDP growth as the dependent variable, while unemployment, inflation, trade balance, FDI, and population growth as the independent variables. So before we run the classical linear regression model, CLRM, assumptions on this model, let us take a rough look at the model first. We can see that the R-squared value is 0.475379. This suggests that 47.54% of the variation in GDP growth can be explained by the independent variables included in the model. This value is common and generally acceptable in economics field. It's because economic models won't explain a high percentage due to involvement of external factors that are difficult to quantify. However, we can find that the p-value of population growth and FDI is larger than 0.05, thus making the variables insignificant at 5% significance level. So now, we need run the F statistics test to really know whether population growth are significant or not in the model. So the null hypothesis is population growth equal to FDI equal to 0, which implies that both independent variables do not have significant effect on GDP growth. On the other hand, the alternative hypothesis is at least one slope coefficient is not equal to 0. This means that at least one independent variable significantly affects the GDP growth. The F-stats value is reported to be 1.796, making it much lower than the F-critical value, which is 4.20. Hence, we cannot reject the null hypothesis. So we can conclude that both population growth and FDI are unnecessary and insignificant. After removing population growth and FDI from our economic model, there are only inflation, unemployment, and trade balance left as the independent variables for GDP growth. To making sure these variables are really necessary and significant, we run another F-test. The null hypothesis and the alternative hypothesis are basically the same as before. However, we can observe that the F-stats value is more remarkable this time, which is 5.458. The F-critical value this time is 3.63, which is lower than 5.458. Hence, we reject the null hypothesis. Now, we are sure that inflation, unemployment, and trade balance are significant and useful variables in explaining GDP growth.
The latest and refined econometric model is GDP equals beta 0 plus beta 1, trade balance plus beta 2, inflation minus beta 3, unemployment plus mu, where GDP is GDP annual percentage change. Inflation is annual percentage change in consumer price index, CPI. Unemployment is percentage of unemployed person from the total labor force. Trade balance is percentage of trade balance from total GDP. And lastly, M is the error term. Once again, we take a look at the coefficient of determination, which is R-squared value. For the refined econometric model, the R-squared value is 0.369. This reflects that the independent variables explain around 37% of GDP growth. As I mentioned before, macroeconomic data involves high variability. Thus, this suggests that the model is able to capture some key relationships. So now we can construct our regression model based on the coefficients for each independent variables that we gain through the multiple regression analysis. The coefficient for inflation is 0.538, unemployment is negative 1.726, and trade balance is 0.176. Thus, the economic model is GDP equals 7.726 plus 0.176 times trade balance plus 0.538 times inflation minus 1.726 times unemployment. Next, we are going to perform several diagnostic tests, such as Ramsey reset test, in order to ensure that our regression model satisfies the classical linear regression model, CLRM assumptions. Most assumptions have their own specific statistical tests or visual inspections that can help us identify the violations and correct them. Before we start with our diagnostic tests, let's refresh our memories regarding the classical assumptions. The classical assumptions refer to the set of assumptions made in the classical linear regression model, which underlie the ordinary least squares OLS method. These assumptions are necessary to ensure that the OLS estimators are unbiased, efficient, consistent, and the results of the hypothesis tests are valid. If any of these assumptions are violated, it may cause unreliable regression results. The first diagnostic test performed is Ramsey reset test, which is used to detect misspecification error. The null hypothesis is the model is not misspecified, while the alternative hypothesis is the model is misspecified. By performing the test, we find that the model is no misspecified. This is proven by the F statistics equal to 1.629, which lower than the F critical value. Thus, we cannot reject the null hypothesis, and this means that there is no omitted variable or incorrect functional form. The next test is the Jarque-Behr normality test. This test helps to determine the residuals normality. The null hypothesis for this test is residuals are normally distributed, and the alternative hypothesis is residuals are not normally distributed. We can observe from the figure that the value of Jarque-Behr statistics value equal to 1.221, which is much less than the critical value of 5.99. Thus, we cannot reject the null hypothesis, and the residuals are normally distributed. The next test is called pairwise correlation test, which is used to determine if there is collinearity between the independent variables. As we can observe from the table, it is found that all of the pairwise correlations value are less than 0.8. Thus, we can conclude that there is no multicollinearity between the independent variables.
Now we're moving on to another multicollinearity test, which is the variance inflation factor (VIF) test. Based on the table, we can observe that all the centered VIF values are less than 5. Hence, we can conclude that there is no multicollinearity between the independent variables. The fifth diagnostic test is the Durbin-Watson D-test. The test is performed to detect autocorrelation in the residuals of a regression model. This is important to ensure the residuals are independent and not correlated. The null hypothesis is there is no first-order autocorrelation, while the alternative hypothesis is there is first-order correlation. Based on the table, the Durbin-Watson stat is equal to 1.999. It falls in the no correlation area. Thus, we cannot reject the null hypothesis, which proves there is no first-order autocorrelation. The sixth diagnostic test is also to detect autocorrelation, but for the higher orders. The test is called the Bruch-Godfrey LM test. So same as the previous test, the null hypothesis is there is no autocorrelation, while the alternative hypothesis is there is higher order autocorrelation. The NR squared is equal to 1.749, which is smaller than the critical value of 5.99. Thus, we cannot reject the null hypothesis, and there is sufficient evidence that the model has no higher order autocorrelation. The final diagnostic test is the White test, which is used to detect heteroscedasticity in the regression model. The test is necessary to check whether the variance of residuals depends on the independent variables or their combinations. The null hypothesis is homoscedasticity, while the alternative hypothesis is heteroscedasticity. The NR squared is equal to 7.822. Thus, we cannot reject the null hypothesis of homoscedasticity. Now, let's begin analyzing the relationship between GDP growth and the independent variable in our model. Inflation. First, we have inflation. The Pearson correlation coefficient is 0.352998, which indicates a weak positive relationship between inflation and GDP growth. As for the scatter plot, we can see this positive trends as inflation increases. GDP growth show a slight upward movement. However, the relationship is not particularly strong. It suggests that moderate levels of inflation could correlate with increased economic activity, unemployment. Moreover, we look at unemployment. Here, the Pearson correlation coefficient is negative, 0.431575, thus shows a weak negative relationship between unemployment and GDP growth. As for the scatter plot, it highlights the inverse trends, where as unemployment rate rises, GDP growth tends to decline. This aligns with the economic theory, whereas higher unemployment generally indicates reduced productivity and spending, which dampens economic growth. Trade balance. Lastly, we will look at the trade balance. Here, the Pearson correlation coefficient is 0.325998. This shows that there is a weak positive relationship between trade balance and gross domestic product growth. As for the scatter plot, it highlights the positive trend, whereas trade balance increase, the GDP growth would increase too.
Hello guys, today we are diving deep into the econometric model that help us to understand and analyze the factors that have been driving Singapore's GDP growth. By the end of this blog, you will have a clear idea of the methodology and insights derived from our study. So let's get started. Firstly, to analyze the factors affecting Singapore's GDP growth, we use a theoretical model that ties GDP growth to several key variables. The functional form of the model are GDP equals to BO plus B1, which is trade balance, plus B2, which is inflation, minus B3, which is unemployment. From this function, we have seen that GDP growth, which are our dependent variable, is influenced by trade balance, inflation, and unemployment. B0 is a constant term that captures the baseline of GDP when all explanatory variables are zero. Trade balance reflects how much a country earns and lost through the international trade. For inflation, it measures the rate of prices for goods and services. Lastly, for unemployment, it represents the percentage of the labor force that is jobless and actively seeking work. Now that we understand the model, let's see how we tested it using real-world data. We have chosen Singapore data for our analysis because it is one of the developing countries. For our data source and variables, we have chosen GDP growth rate for our dependent variable. Meanwhile, for our independent variable, we chosen inflation, unemployment rates, trade balance, population growth, and FDI. We have applied the ordinary least square for our analysis, and we found that the trade balance is a positive coefficient of 0.176, which shows that higher trade surplus have contributed to GDP growth. For inflation, we got a coefficient of 0.538, indicating moderate inflation. But for unemployment, we got a negative coefficient of 1.726, which shows the inverse relationship between joblessness and economic growth. But for other two independent variables, which are population growth and FDI, were statistically insignificant, meaning that they had no substantial impact on GDP in this context. To ensure the reliability of our results, we have conducted several diagnostic tests. The tests are goodness of fit, R-squared, statistical tests, and multi-collinearity checks. For the R-squared test, we have got a value of 0.369, which means the independent variables explain about 37% of the variation in GDP growth. Although this may appear modest, it is common in macroeconomic studies because of the impact of unmeasurable external factors. For statistical tests, we have used F-test, Ramsey reset test, and Jacques-Bera test. For F-test, we have seen that inflation, unemployment, and trade balance are collectively significant. Ramsey reset test has confirmed that the model is correctly specified with no omitted variables. Lastly, the Jacques-Bera test has verified that residuals are normally distributed. Pairwise correlation and VIF test reveal there is no multi-collinearity among the variables, with the highest correlation being just 0.205 between trade balance and inflation. There are three factions that are affected by this data, which are policymakers, businesses, and individuals. Firstly, for policymakers, they need to focus on strategy to enhance trade competitiveness and minimize unemployment. Moderate inflation can be a sign of healthy economic activity. For businesses, they can leverage trade opportunities and align with government initiatives to boost exports and reduce unemployment. Meanwhile, for individuals, they need to upskill, which can help mitigate unemployment and contribute to overall economic stability. While this analysis is robust, there is always room to grow. Here are few areas for future exploration. sector-specific analysis where we can explore how trade impacts individual industries like technology, finance or manufacturing, digitalization and innovation, which we can study the role of emerging technologies on GDP growth. Lastly, global challenges that investigate how external factors like geopolitical tensions or global recessions influence these relationships. For the closure, our econometric model and data analysis provide a structured understanding of the key drivers behind Singapore's GDP growth. By connecting theory and data, we have highlighted actionable insights that can guide policies and decision making. Thanks for joining me on this deep dive. Stay tuned for more explorations into economic trends. Don't forget to like, share and subscribe for more insights.